Hello everyone, myself Brunda. I am studying at Sri Venkateshwara College of Engineering in 5th sem. From the course Computer Network, let me look over about error detection. The contents are error detection and types of error detection. In types, let me look over about parity bit check, cyclic redundancy check and checksum. Error detection. Error detection is the detection of errors caused by noise or other impairments during transmission from the transmitter to the receiver. Error is a condition when the receiver's information does not match the sender's information. During transmission, digital signals suffer from noise that can introduce errors in the binary bits traveling from sender to receiver. That means a 0 bit may change to 1 or a 1 bit may change to 0. Example, if the sender sends the 0 bit and at the end of the receiver side we may get the 1 bit due to the error or noise. Parity bit check. The parity bit check is a network method designed to detect errors and check the integrity of the data received at the receiver side by the sender side. The parity check method adds a bit to the original data for checking errors at the receiver end. In case the received data is damaged, the receiver end will request for retransmission of data from the sender side. We have two types of parity, even parity bit and odd parity bit. Let me look over about even parity bit. In this parity bit type, the total count of ones in the data, including the extra bit, should be even in number. We have the original bit as 101011. 101011 is our original bit. We have 4 number of ones. It is an even, so we add the extra bit as 0. Let me look over about odd parity bit. In this type of parity bit value, the total count of ones in the data including the extra bit should be odd in number. We have the original bit as 101011. We have 4 number of ones, it is an even, so we add the extra bit as 1. So we get the total 5 number of ones. Benefits of parity checking. Simplicity. Parity checks are simple to implement and do not require significant computational resources. Low cost. Parity checks are cheap as they only require adding a small bit to each data unit. Accuracy. Parity checks help ensure the accuracy of the communication as every transmission is checked. Improved security. Parity checks add an extra layer of security to communication and help prevent data loss. Enhancements. Parity check can be enhanced with advanced error detection methods such as cyclic redundancy check or forward error correction. And the drawbacks of parity check are limited error detection. Two-dimensional parity checks can only find code error causing the parity number to change. Unclear detection. A parity check does not help find which bit of code is false. False errors. Parity check can sometimes result in a false positive. Basic security. While a parity check can work as an additional security layer, it can be bypassed with a malicious program that keeps the parity bit same. Let me look over about the second method, cyclic redundancy check. Following are the steps used in the CRC for error detection. In a CRC technique, a string of n zeros is appended to the data unit and this n number is less than the number of bits in a predetermined number known as division, which is n plus 1 bits. Secondly, the newly extended data is divided by a divisor. Using a process is known as a binary division. The remainder generated from the division is known as CRC remainder. Thirdly, the CRC remainder replaces the appended zeros at the end of the original data. This newly generated unit is sent to the receiver. The receiver receives the data followed by the CRC remainder. The receiver will treat this whole unit as single unit and it is divided by the same divisor that was used to find the CRC remainder. If the resultant of this division is 0, which means that has no error and the data will be accepted. Let me look over with an example. We need to perform CRC generator and CRC checker. We have the data bits as 11100 is our original data bit and we have the divisor 1001. At the CRC generator, we add a CRC generator uses a modulo 2 division. Firstly, 3 zeros are appended at the end of the data as the length of the divisor is 4. We have 4 bits. A divisor is 1001, n equal to 4, 4 minus 1 equal to 3. We need to add the 3 zeros at the end of our data bits. So the string becomes 111001. 000 and the resultant string is divided by the divisor 1001. By we need to divide the bit 1110000 with the divisor 1001. After performing the division, we get the CRC remainder as 111 at the CRC generator side. At the CRC checker, the functionality of the CRC checker is similar to the CRC generator. When the string in the CRC checker, we need to add for the original data bits 11100, we need to add the CRC remainder at the end. Before, at the CRC generator side, we added the 3 zeros at the end of the data bit, but in the CRC checker side, we need to add the 3 CRC remainder bits. For the data bits 11100, we need to add the CRC remainder 111. So our data bit will become 111001111 at the receiver end. Then we need to perform the division with the same divisor 1001. We need to perform the division. So if the remainder is 0, our data will be accepted. Let me look over about the third method, checksum. Checksum error detection is a method used to identify errors in transmitted data. The process involves dividing the data into equally sized segments and using a ones complement to calculate the sum of these segments. The calculated sum is then sent along the data to the receiver. At the receiver's end, the same process is repeated, and if all zeros are obtained in the sum, it means the data will be accepted. In the checksum, we perform operation at the sender side and the receiver side. We perform at the sender side and the receiver side. Firstly, the data is divided into k segments, each of m bits. In this original data will be divided into the 4 segment k1, k2, k3 and the k4 with m equal to 8 bits. We have overall 8 bits data. On the sender side, the segment are added using the ones complement arithmetic to get the sum. The sum is complemented to get the checksum. In the sender side, first we need to add the k1 and the k2 segment. We get the value as 01110111100 and we need to add for the given result of k1 and k2 segment, we need to add the k3 segment. Finally, we get 101000000. For that, we need to add the k4 segment. We get the sum as 001000101. For this, we need to apply the ones complement. We get the checksum. At the sender side, firstly we need to add the segments and we get the result as sum, and by using the one complement we get the checksum. Next, what happened in the receiver side is, at the receiver's end, all received segments are added using ones complement arithmetic to get the sum. The sum will be complemented. If the result is 0, the receiver data is accepted. Otherwise, it will be discarded. In the receiver end, we need to send 4 segment along with the checksum. We need to add the k1 and the k2 segment, and the result will be 0111100, and we need to add the k3 segment. So we get the 1010000, and we need to add the k4 segment. So our result will be 001000101. For that, we need to add the checksum. Along with the 4 segments, we need to add the checksum. Finally, we get the sum as 11111111. So after complementing, it will get all the zeros. So our data will be accepted at the receiver end. If we not get the zeros, it will be discarded. Thank you.